So in section 12.1, we take the concepts we learned from determining the intersection or lack thereof of systems of linear equations and applying it to real-world scenarios, otherwise known as word problems. Now, these questions aren't necessarily questions you might ask yourself all the time, but you can see that some of this stuff is useful, particularly if you're trying to figure out some of these puzzles in these problems. So we're going to just do some examples here. And this first example in the guided notes says a jar contains nickels and dimes. And it wants you to refer to nickels basically as the variable n and dimes as the variable d. And together there are 20 coins in the jar. So essentially n plus d is equal to 20. And then the total value is of all the coins is $1.40. And problems like this want you to recognize. Now I know it might not apply much in your daily lives, but nickels are worth 5 cents, right? So basically it's 0.05 n plus dimes. Dimes are worth 10 cents. 0.10 d. And all of that is equal to $1.40 and represented as a number that's 1.40. So the question is, how many nickels and dimes are in the jar? So I'm going to show you how to solve this the substitution way. And if I do that, I'm going to solve for n. You could also solve for d. But basically, if I solve for n, if n plus d is equal to 20, then n is going to be equal to 20 minus d. And now that I know that n is equal to 20 minus d, I'm going to substitute it into this other equation. 0.05 times 20 minus d plus 0.1 d is equal to 1.40. Now, this way is kind of fraught with a few problems, particularly because I know most students are not the best at decimals and not the best at fractions. But if you perform the math correctly, you should still get the correct answer. So basically, let's figure out 0.050, or 0.05, I should say, times 20, what that is as a number. And this is where your calculator is going to come in handy. 0.05 times 20. When I multiply this out, I get 1. 1 minus 0.05 times d is minus 0.05 d. And then these terms just carry down. So plus, even I'm making errors as I'm doing this, plus 0.1 d is equal to $1.40. So this minus 0.05 and 0.1 are like terms. And they actually, if you took 0.1 on a calculator and subtracted 0.05, ask yourself, what would you have if you had a dime minus a nickel? Right? You'd have 5 cents, 0.05. So 0.05 times the dimes, this one carries down, and all that's equal to $1.40. From here, the algebra concept still applies. Subtract 1 from both sides. You get 0.05 d is equal to 0.40. Divide by 0.05. That's actually 8. D is equal to 8. So you have 8 dimes. And if you have 8 dimes, and you know the number of nickels you have is equal to basically 20 minus 8, then you should have 12 nickels. 8 dimes. So yeah, that's the substitution way to solve this. I don't know what you think about that, but it seems like a lot of places you can make a mistake. But you wouldn't be wrong if you did it this way. So that's just one way. Let's take a look at another way. So if I do the elimination way, I'm going to have to multiply either this bottom equation by either negative 20 to get the ends to cancel. Because if I do negative 20 times 0.05, I'll get a negative 1. And if I want to get rid of the d's, I'm going to have to multiply this equation by negative 10. Because basically 10 dimes go into a dollar. Or 20 nickels go into a dollar. So I'm going to choose the times negative 20 route to make my elimination way equation. And when I do that and distribute the multiplication, negative 20 times 0.05n, negative n, negative 20 times 0.1d is going to be minus 2d, and all of that's equal minus 20 times 1.40 minus 28. Minus 28. So I basically have rewritten this equation now. The ends will cancel when I add it together. You get negative d is equal to negative 8, which of course makes d equal to 8. And if the number of nickels and dimes is 20, the number of nickels is 20 minus 8. 12 is the number of nickels. So the elimination way might be, I don't know, a little nicer to do, but you'll see you still get the same answer. So I'm going to leave that up there. You can basically I just want you to see you could also graph this thing too, and eventually if the lines intersect, that will reveal the solution for you as well. So there's 3 ways to solve these, but basically in all these word problems you're setting up 2 lines, and they either intersect, don't intersect, or have an infinite amount of solutions, as you saw in the previous chapter. So I'm going to go on with this other example. A local boys club sold 176 bags of mulch and made a total of $520. It sold 2 types of mulch, the hardwood for $3.50 a bag and the pine bark for $2.75 a bag. How many bags of each mulch did it sell? Right, this is certainly an important problem, I guess, if you are in the business of selling mulch, but not probably the most exciting math problem. But you still need to know how to solve these, not only in Math 1, but also in the SAT exams. They ask questions exactly like this. So if we have 176 bags of mulch, and we're going to say one is mulch that's hardwood, H for hardwood, and P for pine bark, basically however many H you have and however many P you have is equal to 176, right? Because it basically, the information is here. You just need to figure out how to deconstruct it. And together they sold $520. So 350 times H, which is how much a bag hardwood sold for, plus 275, which is how much the pine sold for. All of that was equal to $520. And from here, you have basically 3 ways to solve. You can graph this, graph each, where they intersect, we'll find the solution. You can use the substitution method, or you can use the elimination method. So, I don't know. I think even though as much as people don't like to do it, substitution might be one of the easier ways to solve it in this particular instance. So let's take a look at this first problem, or this first line, if you will. H plus P equals 176. I can very easily solve for H by simply subtracting P from both sides. That'll give me H is equal to 176 minus P. I can then take that and plug it in here for H. 3.5 times 176 minus P plus 2.75 P is equal to 520. And that is a 520. Okay. And right in this chapter, you probably definitely need your calculator. So grab one from the back in the class. That's what they're there for, to use them. So 3.5 times 176 is 616. Right? I'm just distributing multiplication from here. Minus 3.5p plus the 2.75p, and all that is 520. So let's see. These are like terms. And let me switch up the colors. There's too much red. Okay. 3.5 minus 3.5. And a positive 2.75 is going to be equal to a negative 0.75. So you have 616 minus 0.75p is still equal to 520. From here, what's the opposite of positive 616? Negative 616. When you complete that, you get negative 0.75p is equal to negative 96. Divide negative 96 by negative 0.75, and you get the amount of pine bark sold, which is 128. And you know that H, right, we can now take this back. The amount of hardwood is equal to 176 minus 128. Which is 48. So again, you could also graph this, or you could use the elimination method. In this instance, I chose the substitution method. So we're not going to do this one at all. That's enough time for the guided notes in this section, and the homework will just be more examples of similar types of problems.